Rising above the clouds, these mega structures represent the pinnacle of human engineering.
To construct giants like these, engineers push the boundaries of material science and structural design.
We need to reinforce the wind bracing on the upper levels. The simulation shows excessive torsion here.
The paper plan.
As we examine the scale model, we can see how the intricate lattice of the facade integrates with the central core and floor plates.
Warning. Structural integrity compromised. Seismic activity detected.
Look at the stress curve on the monitor.
Incredible. The yield strength exceeded our projections by 15%.
This layout shows the interlocking cages for the main columns. The sheer amount of steel here is what gives the skyscraper its strength.
These elevation markers are off by 3 degrees. We need to recalibrate.
Understood. I'll adjust the parameters on the main console.
This boundary layer between the shale and the clay is critical.
Agreed. The bearing capacity drops significantly right here.
Rig 2, maintain pressure. We need to reach bedrock by sundown.
Before any vertical construction begins, the foundation pit is secured. This intricate web of steel and concrete will...
Watch the left side, bring it down slowly. Okay, easy now, easy. Guide it to the mark.
The grid looks solid, exactly to spec. Yes, the alignment on Sector 4 is perfect. We are ready for the pour.
It appears to be exactly 6 inches. That meets the specification. Please record it.
By immersing the vibrator, air bubbles are forced out, allowing the concrete to settle tightly around the rebar, which is essential for structural integrity.
The heat of hydration is strong this morning.
Yes, the covers are maintaining the gradient. We should be ready for the next phase by Tuesday.
The pour is complete. We are officially ready to go vertical.
Incredible scale, isn't it? The mat looks perfect.
Ascending from the subterranean depths, the structure finally reaches for the sky, marking the start of the vertical build.
With the base secured, the cranes begin their monumental task, lifting the first pieces of the future skyline.
Verify the alignment on Sector 4 before the pour.
It's locked in, but watch the crane swing.
Bring it down slowly, hold it right there. Secure that joint tight.
Almost there, boss.
We need the crane ready for the next lift in 5.
The climbing formwork allows for continuous pouring of high-strength concrete, crucial for the skyscraper's stability.
Kurtzen. This is the core rising phase.
The central spine of the skyscraper ascends rapidly, utilizing advanced...
Check the tension on this joint right there.
Looks good.
We are clear for ascent.
Hold it there, watch the alignment.
Got it. Slow down on the east side.
The tower crane, the workhorse of the site, maneuvers the 20-ton structure into place.
Okay, pull that tight. Got it. Moving to the next one. Make sure the spacing is exactly 12 inches on center over there. We need this section ready for the pour by 11.
The foundation of any megatall structure begins with the reinforcement grid. This dense web of steel rebar...
Keep it moving, watch the rebar. Okay, bring the hose back to the right. We need the bull float over here now.
The stacking of floors is a testament to modern engineering, with each level requiring precise coordination before the next can rise.
All right, bring it down 50 centimeters, watch the alignment.
Copy that, coming down slow.
At this height, the logistics are immense. The crane operator must precisely guide the steel beams to the waiting crew below.
The margin for error is non-existent. He guides the massive steel beams into position, high above the city.
All right, easy now. Bring it down 50.
Watch your spacing on the south side.
The central core and massive steel columns work in unison, transferring the immense weight of the structure.
This wide skyline shot captures the sheer scale of the undertaking. The central tower dominates the city.
At nearly 2,000 feet, the wind alow is a formidable opponent. Yet, the work continues.
As the city reaches higher, the challenge intensifies. Now, the true face of the tower begins to emerge.
The core structure, now complete, stands ready for the intricate process of facade installation.
This extreme heat, followed by rapid cooling in the quench chamber, is what gives the glass its incredible strength, essential for modern skyscrapers.
This macro shot reveals the low emissivity coating being applied, crucial for controlling heat in the world's tallest buildings.
These seals and gaskets are crucial for weatherproofing, while the anchors bear the structural load of the curtain wall system.
Bring it down slowly, watch the left side. Easy now, easy. Send the materials down to the next floor. You got it. Watch the clearance on the south side.
By utilizing a sophisticated network of cables and counterweights, these systems move thousands of people seamlessly.
Watch the beam. Bring it up slow.
Securing the front bolts now.
Clear up here. Let's move it down the line.
The diagram shows this connecting to the upper bus bar.
Got it. Securing the connection now.
Securing the main water and drainage pipes is a critical step. These thick lines are carefully clamped to the structure to prevent vibration and ensure stability.
Ensure the sprinkler head is securely fastened.
It's tight. I'll connect the alarm wiring next.
Good. Refer to the schematic for the correct zone.
Water pressure is steady at 75 psi.
Noted. Electrical load is stable on phase 2.
Energy consumption peaked at 0400. We need to adjust the climate matrix for the residential levels.
Adjusting now. All safety parameters remain green.
But how do engineers manage to clad these mega structures in thousands of glass panels while battling the forces of nature?
By integrating smart glass facades and optimized HVAC systems, these structures maintain comfort with minimal energy use.
Standing tall against the skyline, these glass giants represent the pinnacle of modern engineering and design. As the city breathes below, the final stages of transformation are underway, turning ambition into altitude.
All right, lift it up now. Easy, easy.
Watch the edge there.
Okay, bring it towards me. We're almost in place. Make sure that line is perfectly straight with the laser.
Got it. Almost there.
System shows normal supervision restored.
Perfect. All zones pass the activation and flow test.
As you can see, all systems are fully operational and certified. Excellent. The building is approved for immediate operation.
The wind tunnel allows us to visualize the airflow around the structure before construction begins. As the wind loads intensify, the structure is designed to flex, distributing the stress across the frame.
The oscillation is well within the predicted parameters.
Yes, the system response is optimal. We can sign off on this phase.
Look at that view. We really are above it all up here.
It's beautiful. I'm so glad we moved in.